So this is about getting the reflex ratio from enriching section data. This were asked in 1988 as a 5-mark question. A continuous rectifying column is separating binary mixture of A and B. A is more volatile, okay, into an overhead distillate product containing 95% A. The liquid overflowing from two adjacent plates. So here now we are giving different kind of data. The liquid overflowing from two adjacent plates in the enriching section contains one is 58 point, another is 50%. Or is from the top plate we are having, not the top, or is from the higher plate we are having 58.6%, and from the lower it is 50%. And plate efficiency is 100%. Okay, we can take equilibrium stage, everything. Reflex is at its bubble point. So what is the meaning of that? The your reflex is coming as a saturated liquid. Of course, for every problem we are taking that for granted, but it should be specified. Reflex is at bubble point. There is a meaning of there is a this liquid is at there is a reflex is a saturated liquid. Suppose it is a mixture of vapor liquid, what will be? It is above the bubble point, or it will be between bubble and dew point. Dew point means it is saturated vapor. It is about to condense, and bubble it is at bubble point means it is just starting to vaporize. The first bubble is about to form. Okay, there is many of bubble point. Okay, relative volatility is given. Okay, this relative volatility will be used to relate this y and x. There is a meaning of that. Okay, so we need to find the reflex ratio. So what is given is we are given with the composition in the adjacent plates. Okay, that is composition leaving from the two adjacent plates. So leaving from the top is 0.586, it is below is 0.5. And how do we say it is top is higher? Because the top of the column will be having more volatile. Okay, we have represented these two compositions, and additionally we are given with the relative volatility data. So using the relative volatility data, we can find for this leaving composition what is the leaving composition of vapor, because the leaving contents are in equilibrium. Okay, based on this we can find the leaving composition of vapor. Okay, that composition, actually this meeting compositions are all falling in the operating line, whereas leaving compositions are falling in the equilibrium curve. Otherwise, this point, no, 0.5 comma 0.713 will be a point in the equilibrium curve, whereas this point, or is these are all meeting points. Meeting compositions are falling on the operating line. There's a thing, and this leaving compositions are, or is leaving contents are in equilibrium. See, because of nice mixing and vigorous action, and so the leaving contents are in equilibrium. That is the meaning of the equilibrium stage. Okay, for equilibrium stage, the leaving contents are in equilibrium, and so there is this composition is going to be again contacted, and from the previous try, this is coming. So for this also you can find the leaving composition. So what is the composition of this that is given? For that also we can find the leaving composition. That too, this is going to be your tray one. Tray one, for the tray one, the leaving composition is for the leaving composition is leaving composition you can also find that is going to be, this is your y1, and this is your x1, and x1 and y1 will be on the equilibrium curve. As like that, this x2, this is x2 and this is y2. X2 and y2 will be on the equilibrium curve. And what is this step construction actually? The step is actually from this point actually we'll go down now. This kind of step we'll use to make. So from this point, this is where, or is assume this is where x1, y1. And if you go down, what is happening? This x is not getting changed. Only the y value is decreasing. From y1, it is going to some other value. So from this point, we are going down. So x1 is retained as such. And as like that, we are going to make a step. So this composition, as already we taken that as x2, y2. So this is where x2, y2. So this y2 and value of this y is now retained. What is the value of this y2 is applicable here. So otherwise this point is nothing but x1, y2. So what is the meaning of that? X1, y2. So from that now we can easily take it applicable. No, earlier I simply said like these meeting compositions are falling in this operating line, but you can also now easily accept that because we used to make this step construction. So for the step construction, how do we do? That is this. This is definitely a equilibrium points. X1, Y1 is equilibrium. Okay, that point is known. So on here, as like that, this is X2, Y2. So X1, if you go down, again it is X1. And this point is again simply y2. No, otherwise this y and this y are the same. Otherwise this is simply x1 y2. So what is this? This is x1 y2. So otherwise we are given with this composition. What is needed is you simply find the composition of the vapor leaving the plate which is having the liquid composition of 0.5. So otherwise corresponding to this liquid composition, get the vapor composition. Otherwise this data is solved actually. Okay, that is solved from this our given this equilibrium relationship. So I am using this equilibrium relationship. Otherwise, of course, somehow you have to memorize this equation, which is alpha x by 1 plus alpha minus 1 x. Okay, that way you have to memorize. And this alpha is given as 2.5, and x is for which value of x? No, for the value of this x 0.5 we have to say, solve actually. For a value of 0.5, the y is coming as 0.7143. Okay, that data alone is enough. Of course, additionally also solve for this. This is no, I'm not going to use it. Okay, so otherwise this point is enough. So it is corresponding to the composition of liquid composition of 0.5. What is a vapor composition? So that point is falling on the operating line. So one point is known. Additionally, already we have one point. There is nothing but your distillate. Distillate is at what is it? Bubble point. Not the distillate. Actually, reflex is at the bubble point. So for the bubble point thing, your x and y are the same. No, there is it is simply uh, you have only saturated liquid alone available. So the composition is simply 95%. This is and simply only liquid alone available. Or is that point is this one 0.95, and this point is available. Simply join these 2 points. Or is if given the 2 points, you can solve get the equation. So given the 2 points, form the equation y equal to mx plus c. So c is available, and using the value of c is nothing but xt by rm plus r plus 1, xt by r plus 1 or rm plus 1. In the case of minimum reflex line, it is Rm plus 1, or it is simply R. So you are solving for the R, which is 1.84. So these kind of problems are nice. Okay, another problem is also quite similar to that. Additionally, you're asked to find some energy data also. That also you can go through yourself. I think you can do it yourself. It is also related with that. Okay.